All right, so here's today's do now. Let f be a function with the first derivative defined by f prime of x is equal to 2x squared minus 5 over x squared, for x is greater than 0. It is known that f of 1 is 7 and that f of 5 is 11. What value of x in the open interval 1 to 5 satisfies the conclusion of the mean value theorem f on the interval 1 to 5? Pause the video, give it a try. Feel free to check in with me to see if you got the right answer. Then continue the video. The focus of today's lesson is the derivative and the shape of the graph. We know, mathematically speaking, that the derivative tells us the slope of the tangent line at any given instant. So if we look at this curve here that represents a function f, we can see each of these green lines represents the tangent line. We can see that from the points A to B, that all of the tangent lines are above the curve and they are positive slope. So we would say then that from A to B, the derivative is positive. And we can see that the curve f from big A to B is increasing. So we could say then that when our original function is increasing, the derivative is positive. Now, if we look from B to C, we can see that our curve is decreasing and that all of the tangent lines have slope that are negative. And then from C to D, all our original function is increasing and all of our tangent lines are once again positive. We're going to use this idea to help us today. So we have what is called the increasing and decreasing test. And it says the following. If f prime is positive on an interval, then f is increasing on that interval. And if f prime is negative on an interval, then f is decreasing on that interval. Let's take a look at how this works. Example 1. For the function f of x equals 3x to the fourth minus 4x cubed minus 12x squared plus 5, find the intervals for which the function is increasing or decreasing. Now, according to the increasing and decreasing test, we need to find the sign of the derivative. So we'll start by finding the derivative. So we'll use our power rule. F prime of x is the derivative of 3x to the fourth is 12x cubed. The derivative of negative 4x cubed is negative 12x squared. The derivative of negative 12x squared is negative 24x. We will set this equal to 0 so we can determine the locations where the derivative is 0 and then test around to see where it is positive and negative. So we see that there's a common factor of 12x, leaving us with x squared minus x minus 2 is equal to 0. Factoring again gives us x minus 2 and x plus 1. We can then see that our zeros are 0, 2, and negative 1. Now we're going to perform a sign test. We are going to mark on our sign test our rest points, or the places where the derivative is 0, our horizontal tangents. So we have negative 1, 0, and 2. And what we're going to do is pick values that sit in these intervals and plug them back into our derivative and determine whether it is positive or negative. Let's start with a number to the left of negative 1. How about negative 2? Now note, we're plugging negative 2 into this function. We currently have this function in 3 different forms. I'm going to say that we should use this version of the form, mainly because this is the easiest form to check the sign of. So if I plug in a negative 2, this 12 times x becomes a negative 24. If I plug in a negative 2 here, this is a negative 2 minus 2, which is also a negative. So we have a negative times a negative. If I plug a negative 2 in here, this also becomes a negative. So I end up with a negative times a negative times a negative, which we know is a negative. Now, if I pick a number between -1 and 0, say -1/2, if I plug that in here, we get a negative. If I plug that in the second factor, we get another negative. And if I plug that in the third factor, we actually get a positive, because -1/2 plus 1 is a positive. So this then leaves us with a negative times a negative, which is a positive, times a positive is a positive. If I plug in a number between 0 and 2, say 1, 12 times 1 is a positive. 1 minus 2 is a negative. And 1 plus 1 is a positive. A positive times a negative times a positive is a negative. And then if I pick a number bigger than 2, say 3, 12 times 3 is a positive. 3 minus 2 is a positive. And 3 plus 1 is a positive. So positive times a positive times a positive is a positive. So the question is, where is the function increasing or decreasing? So we will say f is increasing on the intervals -1 to 0 union 2 to infinity, because f prime of x is positive, and f is decreasing on the interval -infinity to -1 union 0 to 2, because f prime of x is negative. Then if you go ahead and graph, you will see that this is in fact the case, that from -1, if you look closely at the graph, you'll see that it is increasing, like we said, from -1 to 0, and then again from 2 to infinity, and it is decreasing from -infinity to -1, and again from 0 to 2. All right, let's take a look at what we call the first derivative test. It says, suppose that C is a critical number, i.e. a place where the derivative is 0 or doesn't exist, of a continuous function. If f prime changes from positive to negative, then it's the location of a local minimum, right? So if we go up and then down, or sorry, positive to negative, yes, sorry, local maximum, we have a peak, right? If f prime changes from negative to positive, then we have the location of a local minimum, right? So it goes down and then up, we have a local minimum. If f prime is positive both to the left and right, or negative both to the left and the right, we get situations like these, and we have neither a local minimum nor maximum. All right, let's go ahead and let's do the first derivative test. Let's determine whether where the function is increasing and decreasing, and find local extremes. All right, so we'll start by taking the derivative. I'm going to use the power rule again. We have f prime of x equals 3x squared plus 6x and equals 0. We'll factor out our GCF, which is 3x, and we're left with our factors, x plus 2 and 3x. We can see that our zeros are x equals 0 and x equals -2. We'll perform a sign test, placing -2 and 0. We'll once again use the factored form. We'll pick a number to the left of -2, say -3. 3 times -3 is a negative. -3 plus 2 is also a negative. A negative times a negative gives us a positive. Now we'll pick a number between -2 and 0. How about -1? 3 times -1 is a negative. -1 plus 2 is a positive. A negative times a positive is a negative. Now we'll pick a number bigger than 0. How about 1? 3 times 1 is a positive. 1 plus 2 is a positive. A positive times a positive is a positive. Now, we can see that f is increasing on two different intervals. Negative infinity to -2, union 0 to infinity, because f prime is positive. And we can see that f is decreasing on -2 to 0, because f prime is negative. Now, according to the first derivative test, if we go from a positive derivative to a negative, so up then down, we have the location of a maximum. If we go down then up, we have the location of a minimum. So we can see f has a local maximum at x equals -2 and has a local minimum at x equals 0. And then if you look at the graph, you can see that's exactly what's happening. Our function starts by increasing until -2 and then begins to decrease and then increases again when it hits 0. And there is in fact a maximum here at -2 and a minimum here at 0.